Hi everyone, this is a video for section 4.4, factoring polynomials, and I'm just going to do a few examples of factoring using the method of greatest common factor. So GCF stands for greatest common factor. So factoring by removing the greatest common factor is like distributing in reverse, and I'll show you what I mean right here. If I look at this, the greatest common factor is 3x. We'll go through how I got to that right now. But if I take out that 3x, and what I'm doing really is I'm dividing both of these terms by 3x, I'm going to end up with x plus 2. So this right here is the factored form of this equation. So this equation, or expression, I should say, sorry, this expression and this expression are equivalent. If I do the distributive property on here, if I multiply 3x times x, I get 3x squared. If I multiply 3x by 2, I get 6x. So when I factored this, I did distributive property in reverse. So a GCF can be just a number. 2, 4, 6, 8, whole numbers is what we're looking for always. A variable, so x squared, x to the third, or could be both. So our GCF up here was an example of one that was both. So one method for determining what the GCF is, now when I look at this, I say, oh, 10 divides into 10 and 10 divides into 50, so I know that 10 is the greatest common factor. But you might have learned at some point, I'm going to first kind of split this in half. I don't want to put that line through the minus sign though, so I'm going to split it in half here. Another way that you probably originally learned factoring was to do a factor tree. So if I do a factor tree on this, I'm going to say, oh, 2 times 5 is 10. Those are both prime numbers, so I can't factor that further. X is also part of that term, so I'm going to put my x's right underneath like that. Now, negative 50, whenever I have a negative, my first branch on my factor tree is going to take care of that negative. So that's going to be negative 1 times 50. Then I'm going to say, oh, 50 can be factored further. That's 2 times 25. And because I just factored this 50 into 2 times 25, I like to put an x through that. So I know I've used that 50. 25 is 5 times 5. So prime number, prime number, prime number. So that's fully factored. Now what I want to do is I want to look at both sides of my line here. So the factors associated with my first term and the factors associated with my second term. And what I want to do is find out what they have in common. So right away I say, oh, well, I have a 2 here and a 2 here. So they both have 1, 2. So I'm going to circle what's common. The circled numbers are going to become my greatest common factor. This term has a 5, and this term has a 5. I'm going to cross off that 25 because I factored it further. So that's everything they have in common. So then what I do is I take what they have in common, which is 2 and a 5. 2 times 5 is 10. 2 and a 5 over here, 2 times 5 is 10. And that becomes my greatest common factor. So I'm just going to write it up here. Greatest common factor is 10. And then what we do is I'm going to say your greatest common factor goes on the outside of your parentheses. Remember, it's like distributive in reverse. So we have something outside parentheses and something inside. And what goes inside is everything that wasn't circled. So the greatest common factor is the circled. Everything on the inside is the not circled. I can also tell you if you have a minus here, you're going to have a minus there every single time. So this first factor, what wasn't circled? The 2 is circled, the 5 is circled, the x is not circled, so that goes on the inside. The second term, what is not circled? Negative 1, circled, circled, and 5. Negative 1 times 5 is negative 5. See, there's that negative. I told you that would be a negative. So negative 5 is the leftovers, or the not circled, from the second term. The x is what was not circled from the first term. So here is my factored form. And if I want to check this, what I do is I do distributive property. 10 times x, 10x. 10 times negative 5, negative 50. Excuse me, I have to blow my nose. So that is correct. This is my factored polynomial. 10x minus 50 is equivalent to this. It's just written in a different form, but these two expressions are equivalent or equal. Let's look at B. This one has 3 terms. Remember, terms are the things separated by a plus or minus. So I'm going to separate it into 3 columns here. If you want to think about it that way, I'm going to do 3 trees, here, here, and here. So 3 trees into 1 and 3. Those are both primes, so I cannot factor that further. X squared, I'm going to write as x times x. 6 trees into 2 and 3. Those are both prime, and I have 1x. 9 trees into 3 times 3, no x. Now let's circle what's common. I have a 1 here, don't have a 1 anywhere else. That's not common. I have a 3, and a 3. So all of these terms have a 3. So circle each 3. Only 1. Don't circle this 3, because they each have only 1 3. Okay, I got an x, no x's. So out of all 3 columns here, the only thing they all have in common is a 3. Okay, so what is common goes on the outside, and what is not common or not circled goes on the inside. If you're factoring out of a trinomial, 3 terms, 1, 2, 3, you're going to have a trinomial here. So I'm going to put this plus right there and that plus right there, just to remind me I'm going to have 3 terms here on the inside. What goes on the inside is everything that's not circled. So I'm going to look at each column or each term and see what's not circled. So 1 x and x is not circled. So I want to multiply these. 1 times x is 1 x squared. In the middle column, or the middle term, what is not circled? 2 and x. 2 times x. In the last column, or the last term, what is not circled? Just a 3. So that goes in there. I always do a quick check just to make sure I did it right. So the way I check is distributive property. 3 times x squared, 3x squared, those match. Remember, if I multiply or do distributive property on this, I should get the problem I started with. So now 3 times 2x. 3 times 2 is 6 with an x, 6x, perfect. And last, 3 times 3 is 9. So that is my factored form. Okay, let's keep going. I think I'll do, I don't know how much time I'm at. Oh, 8 minutes. This is getting a little long. We will do one more. 2 terms divided into 2 columns. This one's a little different. The only coefficient here is a 1. I don't really need to write a 1. I can. I'll write the 1. And then I have 2 x's, so that I write, remember, as x times x. Okay, I have a negative 7, so negatives always write first, take care of that negative, so negative 1 times 7. Now in this case, 7 is prime, so that's actually my whole tree, but I want to include that x. Okay, now let's circle what's common. 1, no 1's over here. This is a negative 1, that's not the same. Looks like they both have, though, 1x. So circle your x. The circled is what becomes your GCF. So in this case, my GCF is x. So Greatest common factor or circled goes on the outside. Everything not circled will go on the inside. If I have a minus here, I'm going to have a minus here. So what's not circled here? 1 times x, x. What's not circled here? Negative 1 times 7, negative 7. X times x, x squared, x times negative 7, negative 7x. So that is fully factored. Okay, I will probably do one more video with maybe a couple more examples and then leave one for you to try.